Okay, so what we already know is, among other things we know now in this unit, how to determine molar mass, how to use molar mass to convert from mass to moles and back. So you can convert from mass to moles or moles to mass. We know how to convert from moles of one species to another. Okay, that's what we've been practicing over the past couple of class days, other than the day we sort of carved out for the lab. So from all of this, we're ready to do what's called mass to mass stoichiometry. Mass to mass stoichiometry. 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 Okay? Stoichiometry. Yep, there you go.
There you go.
All right. So what I want to do is I'm going to give you a problem. I'm going to show you how we're going to solve it. Okay? But to make my life easier, I'm going to start on this sheet of paper and I'm going to turn it sideways. This way. No. This is only the first part of what will take you a whole page.
Lovely.
Okay? All the post-lab work we're going to eventually be able to do from the lab we did yesterday will take an entire page of calculations. But most of them are kind of like repeat of the same calculations. Okay? You'll have to calculate percent, but hey, we were just talking about how to calculate percent. You know how to calculate the percent on the grade, right? Take the points you earn, divide by the maximum points, multiply by 100. We're going to be calculating a percent in all of this. Well, that's just taking the part you got, divide by the whole, multiply by 100. That's what all percents are. Okay? Percents are just a way of representing a fraction. All right? So, anyway, so here, let's just make up a problem here. Let's suppose 12.00 grams of ethane are burned in air where there is, let's just put that in parentheses, where there is, well, you can't see that, where there is more than enough oxygen. Okay? So 12 grams of ethane are burned in air where there is more than enough oxygen. Okay? There always is more than enough oxygen in the air. Okay? We basically don't have enough fuel to use up all the oxygen in the air. Alright? Can't do it. So there's always, anytime we burn something in the air, there's always plenty of oxygen. Okay? Got it? Alright. What mass of carbon dioxide is produced? What mass of carbon dioxide is produced? But these kind of calculations are basically central to the idea of the things that they talk about in the news sometimes, about all the carbon compounds that are in our atmosphere that cause global warming. Okay? If in fact that's what's happening. There's no believing in global warming. It's not a matter of belief. Okay? Is the planet warming up? The data shows it. I'm a science teacher. If the data shows it, it must be, I have a reasonable expectation that it's true. but science doesn't prove anything. Remember? Unit 1? Science doesn't prove things. Science is about finding evidence to support an argument. Remember that? Okay?
But how come you hear
It's not a matter of belief.
scientists prove that?
Well, that just shows that whoever's saying that doesn't understand science.
A lot of people.
That's right. A lot of people don't. But I don't want you to leave this class not understanding that basic thing about science. Science doesn't prove things. Okay? Science offers evidence to support an argument. Got it? Now it can be really, really strong.
So how do you prove things?
Well, you don't in the sciences.
What's proving them? What is the difference in proving something?
You can prove things in math, but you don't prove them in science. Okay? You can prove beyond a reasonable doubt in a courtroom, or you can prove with a preponderance of evidence in a courtroom, depending on what level of court hearing it is. Okay? But science doesn't prove things. Science offers proof for things, but not prove things. Okay? That's just a review from Unit 1. Let's get back to this. Okay? I don't want to belittle that. That's like an essential thing that you need to know in this class. When you leave this class, I want you to know those things. Okay? That's one of those critical things you need to know. All right. So let's start with our starting amount, 12 grams of ethane. What we're going to do with the starting amounts. Yep. And what is the formula for ethane? Really? How many carbons in an ethane? 2. So let's go down here and we'll make a structural formula. 2 carbons. The ANE part of this tells me there's only single bonds between the carbons. No double bonds, no triple bonds. So I need to have as many hydrogens as are necessary to fully and completely bond all the oxygens. So I hear several people saying 6. That's because each carbon has to have 4 bonds, because carbons start with 4 valence electrons. Wow, I'm reviewing all the way back to Unit 2. Okay, so that's C2H6. All right. Now then, first thing I got to do, one of the things we said on Monday, you got to go where first? Said it again on Tuesday. Where you got to go first? Huh? What is that for? Moleville. There you go. Got to go to Moleville. Yes. Yes, you can use the restroom. You also may use the restroom. Oh. All right. So, how do I get from the grams of this to moles of this? How do I get from grams of this to moles of this? Well, what conversion do I use? You did this last night.
Yep.
Add atomic numbers. What do we call that? Molar mass is what it's called. So we need to calculate the molar mass of this chemical. Please do so. You did it last night. I just reviewed it and showed you how to do it again. Okay? Calculate the molar mass of this chemical, please. Oh, yeah, that's the only chemical I got up here. There you go. All right. I know I'm being a little bit sarcastic, but I really would like you to kind of think it through, okay? Huh? Play you?
Yeah.
Okay. You say so. All right. No, I'm not. All right. Give me your attention, guys. Give me your attention. Okay, so what we're trying to do is we're going from 12 grams of ethane, and we're eventually going to get to the mass of carbon dioxide. We've got grams of a chemical, and we always have to go through Moleville. You've got to go through moles. You can't get anywhere without going through Moleville. Okay? All right, so whoever's singing needs to stop.
You don't like it?
I don't like the disruption. So, if you can't just in your head figure out the formula for ethane, you should know ethane has 2 carbons bonded together, and then you can figure out how many hydrogens to put around that to figure out the formula. Okay? Once you know the formula, then you're going to calculate the molar mass in this fashion. You list each of the elemental symbols in the formula. Write down the atomic mass of each element, multiply that mass by the number of those atoms in the formula. I have 2 carbons and 6 hydrogens, so I'm multiplying by 2 and 6. This is the atomic mass of hydrogen and the atomic mass of carbon. Then I'm going, because multiplication, you know, is just another way of adding things, right? It's just repeated addition. That's all multiplication really is. So by multiplying these, then adding these, I'm really just adding everything up. Okay? But when I add them up, I do have an empty slot here. So this number at the end, we don't know what it would be if this number were more precise, so we round it off. So we're going to round it off to 30.0690 grams of ethane, and that is the molar mass. However, since the definition of molar mass is the mass of a substance in 1 mole of that substance, since the definition of molar mass, or one definition of molar mass, is the mass of a substance in 1 mole of that substance, we're going to write our molar masses in here that way. The mass of a substance in 1 mole of this same substance. Okay? When we do that, we have an equality statement. Since we have an equality statement, we have what we need to write a conversion unit. Okay? In this class, equality statements are always required for writing conversion units. So now we have all the stuff we need to convert this into moles and get to moleville. Alright? We want to match the units at the top here, units and species at the top here, with the side of this equality statement. Okay? That fits. So I have grams of the units and species, or grams of ethane. This side of the equality statement is in grams of methane, or ethane rather. So this is the side of the equality statement that's going to go on the bottom here. And we do that, as we'll be able to see in a minute, so we can cancel units and species. Okay? But first, the other side of the equality statement has to go on the top. So, just like x's and y's in algebra class, if I have the same units of measurement or the same chemical species on the top of a fraction and the bottom of a fraction, you can cancel them. Okay? So the units we have left right now are moles of ethane. Okay? Now, we are going, in the process of this stoichiometry, we're going to go from this species to a whole different species. We're going to go from this species to a whole different species. So the other day, earlier this week, when we're taking notes, we're talking about how you can do these conversions. So what conversion do we need to go from one species to another? What? Moles over moles. That's called a molar ratio.
I thought it was moles over molecules.
Where do we get a molar ratio from? Not molar mass. This is molar mass, and we didn't get from moles of one. We get from one species to another using molar mass. We went from mass of a species to moles of that species. Did I give you a copy of this? I'm going to give you a copy of this, but you have a simplified version of this. We talked about this yesterday. To go from moles of one substance to moles of another substance, you have to go through and use a molar ratio constructed from coefficients and a balanced chemical equation. So we need a balanced chemical equation. Huh? Okay, we need a balanced, yes we did. We practiced building molar ratios. What we haven't done was to put it into a bigger problem like we're doing now. Okay? So, we have to have a balanced chemical equation to convert from this species to some other species. So that's what I want you to do right now. So write a balanced chemical equation as is described in this problem. So write the equations without balancing them, then balance the equation, and then we can build our molar ratio. Everybody understand?
How do you know you had to go from moles to different species?
Because it says I have ethane here, and I want the mass of carbon dioxide. That's a different species. That makes sense? So we're going from one chemical to another. And the only way you can go from one chemical to another is a molar ratio. The only way you can get a molar ratio is a balanced chemical equations. And the video on Monday said chemical equations that aren't balanced are useless. Good. All right. So let's balance the equation, please. Work with a neighbor. Get a learning partner. And get her done. Okay. Okay. So I have here's the balanced equation. All right. We've been practicing that. That was all last unit. Okay. You have to go about predicting the products. In the case of a combustion reaction, it's always CO2 and our water. Water is always steam because of the heat. Use an atom inventory to balance. Don't fail to write the math part down. It seems kind of simple, but after a while, it's kind of hard to keep up with all of it. It's a lot of little bitty math, simple math things, but a lot of it. So write it down and be sure, and you should come up with these coefficients: 2, 7, 4, and 6. Okay? But you can go back and review the videos and the notes from Unit 5 if you need to practice this stuff. Okay? Or come and see me. I'll help you with it. Now, with a balanced equation, then I can write a molar ratio. Okay? If I have moles on the top of this fraction, and we've gotten rid of all the other units and species, we cancel them out. If I have moles on the top of this, and a species C2H6, what units and species do I need in the bottom here? Moles of C2H6. Okay? That's the easy part. Alright? What are we trying to find here? Well, we are trying to find grams of carbon dioxide, but first, before we can get there, we've got to find moles of substance B. Right? So I don't want right now, not yet, grams on the top. I want moles on the top of substance B. And what is our substance B here? What are we trying to get to? CO2. Okay? So we just need the coefficients now in the problem that fit with us. So what coefficient do I put in front of CO2? 4. What coefficient do I put in front of the moles of ethane? 2. All right? Okay, how do we simplify? Cancel. Cancel as you go. Okay. Now, we're at moles. And how do you go from moles to mass or mass to moles? Right, you will have moles on the bottom. How do I get grams on the top? That's how I get mass. How do I get grams on the top? What do I have to do to get mass? We don't have it yet. How do you go from moles to mass or mass to moles? What conversion? Moles to mass, mass to moles. You did it last night. It's homework. I'm sorry. I assigned it 2 days ago. I graded it today. To go from mass to moles or moles to mass, you need molar mass. Moles to mass, mass to moles, molar mass. Moles to mass, mass to moles, molar mass. But we don't have it for carbon dioxide. We need the molar mass for carbon dioxide. Calculate molar mass for carbon dioxide. Please do that now. All right, so here's the molar mass of carbon dioxide. Now there's no reason to round off over here because I don't have any empty slots. Okay? When we did it earlier for ethane, we needed to round off because of the empty slots. I don't have any empty slots here, so I don't need to round off. So the molar mass is 44.0095 grams for carbon dioxide. But we are always going to write that equals 1 mole because that's what molar mass is. The mass of a substance that equals 1 mole of that substance. And that also, by writing it in this equality statement form, it allows me to have what I need for this conversion unit. Now, as Connor said, we already know we have moles on the bottom, so I'm going to put that 1 down here. And the mass is here, 44.0095 grams of CO2. Now, let's simplify. Cancel as you go. Okay? And we're ready to do the math. Now look. I won't tell you, it's not that bad. It's not, really. Just don't make it hard. Let me tell you how to do this. This is simple. Get your calculator out and get ready. Alright. Remember, multiplying by 1, don't do it. It's unnecessary, right? Multiply all the numbers except 1 across the top. Do that now. Multiply all the numbers across the top except the 1. Okay? Don't write the answer down. Just do the math. You got that?
Yeah.
Now then, for each number we need to divide by on the bottom, and remember dividing by 1 is kind of useless. We don't do that, okay? For these two numbers here, we're going to divide and hit equals in between. So we're going to divide by this, hit equals, divide by this, and hit equals, okay? Do that.
Then divide that by 2. Yo, 35. Can't see yours.
Okay, that's what I got.
That's not what I got. Oh, yeah, it is. So it just equals that number?
We've got grams of CO2, but got to round it off. Now, 4 and 2 are counting numbers. We're not going to use that for figuring out significant digits. We're only going to look at the measured numbers like this and these two calculated numbers. And of those numbers, which one has the least digits? 12. So how many digits do we want in the final answer? So we're going to undo on everything past this 2. Draw an arrow to round off. And Rima, what's happening to you points to something that everybody needs to do. Would everybody please listen? Do your math at least twice. If you don't get the same number twice, keep doing it till you figure out figuring out where the error is, okay? All right? Now, that's a lot of math, but it's not something that's impossible. We've been doing this. We've been building up to this point, building up skills and knowledge to be able to get here. Still not getting it? And you're multiplying everything across the top, hitting equals, dividing by this, hitting equals, dividing by this, hitting equals. Oh. Boy, time just flies when you're having fun.
So dumb. I love the comments. They're the dumbest people ever. No, I love them. No, you know who's dumb?
All right, so there's your homework problem.
Yeah. Oh my God, yeah. What?
There's your homework problem. If 10 grams of hydrochloric acid is reacted with more than enough potassium hydroxide, what mass of potassium chloride will be produced? Well, of course you don't know. You haven't done the stoichiometry. Stoichiometry.